All right, hello students, welcome back. We left off on number 8. The length of pregnancies are normally distributed with a mean of 271 and a standard deviation of 20 days. If 64 women are randomly selected, this is where we transitioned from finding the probability of one to a probability of a group. This was our group. When we switched the previous pages, we found the probability of one person, one item, one car, one thing. Now we're doing groups of things, and we have 64. Find the probability that they have a mean pregnancy between 271 and 273 days. The formulas for a group. The mean of the group, remember X bar means group, is equal to the mean of the population. And the standard deviation of the group, X bar means group here, is equal to the standard deviation of the population divided by the square root of n, where n is the number of people or items in the group. All right, so here we go. Let's do it. The mean of the group equals the mean of the population, which is 271. The standard deviation of the group equals the standard deviation of the population divided by the square root of n. The standard deviation is 20 divided by the square root. How many people are in the group? There's 64 women in the group divided by the square root of 64. You don't need to find that. The calculator will find that. And I want the probability between 271 and 273. So I put a 271. I put a 273. X bar goes in the middle, and we always use less thans. Now you're going to go back, just like you've been doing, to normal CDF. That's what this chapter is all about. So hold on, let me hit clear. Go to second dister. Normal CDF is number 2. The lower bound is 271. The upper bound is 273. The mean you found up there is 271. Now watch how I type in the standard deviation. It's 20 divided by the square root of 64. Hit paste, hit enter, and you should, if you get it right, get 0.2881. 0.2881, and there is your answer. Assume that the heights of women are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5 inches. Now 100 women are randomly selected. Find the probability they have a mean height greater than 63 inches. The mean of the group equals the mean of the population, which is 63.6. The standard deviation of the group equals the standard deviation of the population divided by the square root of n. The standard deviation is 2.5 divided by the square root of 100, because there's 100 people in the group. And you want to find the probability that they have a mean height greater than 63. So you want this to be greater than 63. So let's look at the picture of this. Greater than 63 means it's going on and on and on forever, all the way up to infinity. So go to second dister. Normal CDF is number 2. The lower bound is 63. The upper bound is infinity, which is 999,999. The mean is 63.6, and the standard deviation is 2.5 divided by the square root of 100. Hit enter, and you should get 0.9918. And number 10, the body temperatures of adults are normally distributed with a mean of 98.6 and a standard deviation of 0.60. 25 adults are randomly selected. Find the probability that their mean body temperature is less than 99 degrees Fahrenheit. The mean of the group equals the mean of the population, which is 98.6. The standard deviation of the group equals the standard deviation of the population divided by the square root of n, which is going to be 0.60 divided by the square root of 25. And I want the probability that their mean body temperature is less than 99. So you want less than 99. If you look at a picture of this, here's 99, and you want everything to the less than of it, to the left of it, which means that it's going all the way down to negative infinity. So if you go to second dister number 2, the lower is the negative infinity, which is negative 999,999. The upper is the 99. The mean is 98.6, and the standard deviation is 0.60 divided by the square root of 25. Keep hitting enter, and you should get 0.9. If you round that to 7, it's a 5 or above to give him a shove, so that's going to be 0.9996 as your answer to that one. And we are done with that page. Let's keep going. Number 42. 2% of hair dryers, so that's 2% of hair dryers produced in a certain plant are defective. Estimate the probability that of 10,000 randomly selected hair dryers, at least 219 of them are defective. So step 1, I need to find NP greater than or equal to 5. So let's figure all this out. 2%, percent, that's your P. N is the total amount that you're studying. So the total amount of hair dryers that are produced is 10,000. So that is your N. So you're going to do 10,000 times 2%. Move it over 2 places, 1, 2. That's 0.02 greater than or equal to 5. 10,000 times 0.02 is 200. Greater than or equal to 5. 200 is bigger than 5, so we can keep going. Remember, if this number isn't bigger than 5, then you stop and you're done. And Q greater than or equal to 5. Now, how did we find Q? Let me write it up here. Q is equal to 1 minus P. P was 2%. So 1 minus 2% would be 1 minus 0.02 is 0.98. So this is 10,000 times 0.98 greater than or equal to 5. And 10,000 times 0.98 is 9,800. Is 9,800 greater than or equal to 5? Yes, it is, so we can keep going. The formula for the mean is the same as the formula up above, mu equals NP, and you just figured out NP to be 200. The formula for the standard deviation is the square root of NPQ. So you're going to take N, the square root of N, which is 10,000, times P, which is 0.02, times, we already have the N, so now we need the Q, which is times 0.98. And you don't need to figure that out. Your calculator will do it for you. Draw, label, and shade the picture. So I want to find the probability of at least 219. This is when we did our continuity correction. Continuity correction. And the formula for the continuity correction is plus and minus 0.5. So what we did is we put a bar. And if this is based on what I'm looking for, this is based on my probability, and it says find the probability that at least 219 are defective, so we put 219 inside. Then we add and subtract 0.5, which would give you 218.5 and 219.5, and I want the probability of at least 219. If I want at least 219, I want 219 or more. At least is the minimum, so 219 or more. So this is X greater, what you shaded is 218.5 all the way up to infinity. So go to your calculator, go to second dister, normal CDF is number 2. The lower, what you shaded here, your lower bound is 218.5. Your upper bound is infinity because it goes all the way up to infinity, which is 999,999. The mean we found right up here in step 2 to be 200. And the standard deviation is the square root of 10,000. I might have got carried away on my zeros. I think I have one too many zeros. Hold on there. 10,000 times 0.02 times 0.98 is your standard deviation. Hit paste, hit enter, and your answer should be 0.09, and that 7's going to round the 1 to a 2, so 0.0932. Is this event usual or unusual? Remember, to be usual or unusual, to be unusual, it has to be less than 0.05. Is that number less than 0.05? To be less than 0.05 would make it unusual. Is that number less than 0.05? No, it is not. So therefore, it is usual. And we are done with that page. And we just have chapter 9 yet to go. So I'm going to put this into L1. I'm going to put these into L2. And then we'll be ready to make a scatter plot. So let's go to clear. Let's go to stat edit, and let me clear out my list. Clear down. And I have 0, 3, 6, 4, 9, 2, 15, 8, and 5. And then I got a 98, an 86, an 80, an 82, a 71, a 92, 55, 76, and 82. And then it says the data below are the number of absences and the final grade of 9 randomly selected students from a statistics class. Sketch a scatter plot for the data, label the axes, and determine whether there's a positive linear, a negative linear, or no correlation. So here we go. So you entered these into L1. You entered these into L2. Give me 1 second here to get to the right page. Okay. Hold on, be patient. All right. So let's make a scatter plot. Go to second stat plot. We always hit number 1. Make sure it's turned on. Scatter plot is the very first picture, so hit enter. My X list and Y list, I entered my information into L1 and L2, so I need to change that to an L2. Hit enter, and then to remember to make it appear on your screen, you hit the word zoom and you hit the number 9, and then we're going to sketch that onto our screen. So a dot, a dot, a dot. These two kind of go beside each other, and then it kind of keeps coming down, and then you have this one all the way down there. And if I was to label this, this is your x-axis, this is your y-axis. So you have number of absences on the x-axis, and you have final grade on the y-axis. And I'm going to stop right there and load up the last and final video. Hold on just a second, please.